Okay, now we go on to part D of the questions, and you are asked to find this wavelength of the waves. Okay, and the formula that we're going to use is V is equal to F lambda, and in this case lambda will be equal to V over F, and V is given as 325 and F is 250, so the wavelength will be 1.30 meter, and now it's 3 sig fig. Alright, and because this is 3 sig fig, this is 3 sig fig, so final answer is 3 sig fig. Alright, now let's move on to the next question. It says that now the sound passes from air into steel. Okay, and they are asking you to state, alright, the speed of the sound and the wavelength. So there's no explanation, but just simply state. But remember, the speed of sound is solid is the fastest, then followed by liquid, then air. That means the velocity actually decreases this way. Alright, decreases. Okay, right. So in this case, that means when the sound passes through solid, it should increase. Right, it should increase. And then now you got to talk about the wavelength, but before that we must remember V is equal to F lambda. And so in this case, if the speed of sound in steel increases, and bear in mind frequency is always constant, so your wavelength would have actually also increased. Okay, so remember that, but there's no need to explain, you just have to state, will do. Okay, let's move on to the next question. Question number 7. Okay, question number 7 is about electrostatic. Okay, by looking at it, it says that the electrons carry negative charges, and electron can move through the metal. So right now, there's a negative charge rod. Okay, it's brought towards the top of the metal rod. Okay, charge rod, okay, metal rod. So right now it says the foil move away. That means actually the foil repel, right? Okay, so if they repel, that means this part and this part must have the same kind of charges. Make sense? Alright, same kind of charges. Okay, so now you got to explain why. Okay, so in order to do that, first of all, let's look at let's look at the diagram. Okay, so if this is actually a negative charge rod, okay, you would have induced positive charge here. Alright, and so your negative charge will be repelled. And in this case, the negative charge will be repelled to the end here, as well as to here. Okay, so actually that's the reason why this metal foil repel, because of the negative charge. Okay, so how are we going to explain that? So maybe we can start off by saying that the negative charge, the negative charge rod, okay, will repel, okay, negative charge, okay, to the bottom, alright, of the rod, bottom of the rod, okay, and the metal foil, okay, and metal foil. So in this case, so right now you gotta explain. Then the foil will be repelled, okay, from the rod. And you remember we said that we must write down the reasons, the principles, the laws. So then you said, okay, that since like charges repel, okay, now do take note that you are encouraged to draw the charges distribution on the diagram, and you may even write down, say, refer to the diagram, and that will help in your explanations. Okay, right. Okay, let's move on to the next question, question number 8. Okay, Now question number 8 is about DC circuit. Now so by looking at this diagram, you know that this resistor and this resistor is in parallel. So remember all the properties of parallel circuit. Okay, let's look at the first one. You're supposed to calculate the current. You're given the amount of charges, you're given time, so of course this one is I is equal to Q over T, and in this case Q is 90 and I is 60 seconds. Remember, you got to convert this to 60 seconds. Okay, alright, and you have got 1.5 ampere. Okay, 2 sig fig. Again, as you can see here, is 2 sig fig. So final answer is 2 sig fig. Now the next part of the question is asking you to find the current in the 8 ohm resistors. Now remember the ratio rules I did mention before. Okay, so you look at the diagram, the current goes here, I, and then you will split into I1 and I2. Alright, so how to find I1? Okay, so I1 will be equal to using the ratio. The ratio you always use, since you are finding I1, you will use the ratio here. So you use 4 over 12. Okay, the ratio of the resistance multiplied by I. And in this case, it will be 4 over 12 multiplied by 1.5. And you would have got 0.50 ampere. Okay, 2 sig fig. Okay, remember that, huh? So if let's say you were to find I2, I mean this is not in the questions, I2, then you would have used this resistor instead. It will be 8 over 12 multiplied by I again, and you would have got 1.5 ampere. Okay, so please remember this ratio method to solve for current. Alright, remember that, huh? Okay, now so the answer for this one is 0.50 ampere. Now let's go on to the next part. You are supposed to find the potential difference across the 8 ohm resistors. Okay, so let's come back to here. Now potential difference across 8 ohm resistors. So in this case, you have to ask yourself, alright, do you know R? Yes, you know R. Do you know I? Yes, you know I. You just found out from here. So in this case, you can use your formula V is equal to Ri. Okay, and R will be 8 and I would be 0.50. So answer would be 4.0 volts. Clear? Okay, let's move on to the next part. Now the question asks you, which of the two resistors transfer more energy per second? Now it says energy per second. This actually refers to power. Alright, okay, so if let's say you talk about power, and now the next question is, how do we find power? Okay, power, you can use P is equal to I square R. Now so if you look at it, right, the current flowing through these two resistor is, okay, you can work out, of course, right, from here you can work out like the P 8 ohm, how much is it equal to, and P 4 ohm, how much is it equal to, right? But of course there's another way of finding it. Okay, is to look at this parallel circuit. Alright, now if this is parallel circuit, okay, that means the voltage is the same. Right? Okay, remember, voltage is the same. So right now I'm going to come back to here. If voltage is the same, that means power, I can use this formula, V square over R. Right? Okay, so if you look at this, now you realize that since this is the same, it's a parallel circuit, this one If is bigger, your power will be smaller. If this is smaller, your power will be bigger. Make sense? Right. So for that matter of fact, okay, you'll be able to explain the answers now, because you can use this formula. You said that you quote a formula, P is equal to V square over R. Then you said that the V is the same as okay, is their parallel circuit. So that would imply that R increase, so your P would have decreased. Okay, so that means this will imply that your 4 ohm resistors will have the bigger power. Alright, and that will also means more heat dissipated. Okay, clear? So I repeat, we are making use of this formula, and we are making of this idea that dV is the same. Alright, if you do not want to, alternatively, of course, you can just work out the values of the power, alright, using the I that you can calculate and the R that is stated. Okay, right, let's move on to the last questions here. In electric iron, okay, should be earth. Explain what is how the earth protects the user when the fault occurs. Okay, this is a very important question, I must repeat. So this is how you write. You can say, if there is a leakage, alright, of current. Now, leakage of current to where? So you must say to the casing. Okay, alright, then you can say that the current will flow to the ground or earth. Okay, because I asked you, right, why it should be earth. Okay, so you say flow to the earth. Okay, then at the same time, okay, now the fuse, okay, connect in the circuit, and the circuit will blow. Alright, and so supply will be, okay, cut off from the appliances. Okay, thus you can protect the user. Okay, now a common mistake actually is to say that just simply mention that the current will flow to the ground. Okay, you just mention this. This is not sufficient, because you have to talk about how you protect the user. So you have to first of all explain about this leakage current, and then so it will flow to the ground, and then the fuse will blow, and then it will cut off or isolate the supply from the appliances. Okay, this is very important. So remember, this is the explanations for earthing. Okay, just in case the exams come out this question on earthing. Clear? Okay, this is not in the syllabus, so don't bother. Alright, we are going to go on to these questions, and I think I will put it in part 3. Okay, for the time being, done.